Hello class, these are our Algebra 1 notes for section 216. We're solving linear equations by multiplying. So this is the elimination method again. So let's go ahead and make a quick note of that. So remember, elimination is when we are adding our equations together to eliminate a variable. So yesterday that was really easy. Today we're going to have to do a little bit of extra work before we can start eliminating. So I'm looking at question 1. And what I'm noticing is I don't have like a 6x and a negative 6x that I can add together to eliminate them and just get 0. So that's what I really want here. Instead, I have a 6x and a 2x. So I'm going to need to multiply my second equation so that we have opposites and we can eliminate x. So if I have the top one is a positive 6, I want the x in my second equation to be a negative 6. So I'm going to multiply by negative 3. So I'm going to leave the first equation the way it is, 6x plus 5y equals 19. And the second equation I'm going to multiply through by negative 3. We're multiplying both sides. We're distributing it to everything so that we have an equivalent equation. So this is negative 6x, negative 9y or minus 9y, and negative 15. So now I want to go ahead and add them together. 6x and negative 6x make a 0. 5y and negative 9y make negative 4y. 19 and negative 15 make a positive 4. So my next step is to divide both sides by negative 4, and y is equal to negative 1. All right, now I want to go ahead and solve for my x. And remember, we do that the second one using substitution. So I can use my equation 1, my original one, my equation 2, or I could even use my equation 2 that I've multiplied by negative 3. All of those equations are equivalent. They're all going to give me the same answer for x and y is what we're looking for. So I think I'm going to use this one right here. 2x plus 3y equals 5. So 2x plus 3y equals 5. And I want to substitute negative 1 in for y. I think I misspoke earlier when I said they were all equivalent. They will all give me equivalent answers. But my equivalent equation is like this one when I multiply by negative 3. So we should probably clear that up. I need to keep working on this one. So 2x plus negative 3, or 2x minus 3 is 5. We're going to add 3 on both sides. And then we're going to divide by 2, and so x is equal to 4. I ran out of space for that one. So I need to make sure I'm writing these as an ordered pair. Ordered pairs are x comma y, 4 comma negative 1. Okay, so on my next one, it's going to be even more work. So this time I don't have an x or a y with anything in common. Like on the last one, I knew that 6 was a multiple of 2, and that was an easy starting point. On this one, I don't have anything like that. But what I do have is a positive 7x and a negative 7x. So I'm going to multiply the top one by a positive 4 and the bottom one by a positive 7. And then we'll have a 28 and a negative 28. So let's just go ahead and go through and do our multiplication. This is not the only way, okay? I could have instead multiplied the top one by a 5 and the second equation by a negative 3. Then we'd have a positive 15y and a negative 15y. That would work as well. So there's definitely more than one way to solve. I'm just capitalizing on the fact that I already have a positive x and a negative x. So that way I don't have to multiply by negatives. I find that if I do less with negatives, I make less mistakes. So equation 1 is now 28x plus 12y equals, let's see, 33 times 4. That's going to be 132. And then in my second equation, I have got to multiply by 7. And I have a negative 28x and a plus 35y. And then I need to know 39 times 7 is going to be a negative 273. And then I always like to take a second and just make sure that I've done all of my distributing. So I multiplied the top one by 4 all the way through. 7 times 4, 3 times 4, 33 times 4. They were all positive to start with. They're still all positive. And then I just do the same kind of quick check in my second equation, that I multiplied everything by 7 and that my signs are correct. So now that I've double checked everything, I'm going to go ahead and add my equations. 28 and a negative 28 is going to eliminate. We have 0. Now we have a 47y. And then I have to figure out, let's see, 273 minus 132. Let's see, 273 minus 132. That's going to be a 241, and the negative number is bigger, so it's negative 141. Then we're going to divide both sides by 47, and I'm pretty sure this is 3. Yes. Negative divided by positive is going to be a negative 3. Then I do need to use substitution to go back and find my value of x. So I'm going to use the 7x plus 3y is equal to 33. And remember, I'm going to replace y with negative 3. So 7x plus 3 times negative 3 equals 33. 7x minus 9 equals 33. We're going to go ahead and add 9 on both sides so that 7x is 42. And then divide by 7, and x is equal to 6. So 6 comma negative 3 is our solution on this one. So remember that ordered pair is that place where both lines would cross. 2 more problems. So on the next one, what I notice is I don't have my x's and y's lined up again. So I want to go ahead and subtract 2y from both sides on my first equation because I want it to be a 3x minus 2y equals 2. So when I subtract 2y on both sides, I'm effectively moving it to the left-hand side of the equal sign. The 2y minus the 2y on the right is going to zero out. So I am moving that over so that my equations can line up. My second equation is 2x plus y equals 13. So now I have to decide what to do next. And I can already kind of see that if I look at my y's, one equation's negative, the other one's positive. And all I would have to do is multiply the second one by 2, which makes it really easy. So we're going to keep equation 1 the way it is, 3x minus 2y equals 2. The second one is now 4x plus 2y equals 26. And then we can add them together so that 7x is equal to 28. The 2y minus 2y, or negative 2y plus 2y, zeroes out. Divide both sides by 7, and x is equal to 4. And then we need to go back and find our y. So 2x plus y equals 13. Remember, I can write down either equation, use either equation. Both are correct. We're going to substitute 4 in for x, so we're replacing the x with a 4. 2 times 4 plus y is equal to 13. We'll multiply the 2 times 4 and then subtract 8 on both sides. And so let's see. Y is equal to 5. So 4 comma 5 is our answer. If I wanted to check, I would go back and I would use this ordered pair and check in both of them. I would do 3 times 4 equals 2 plus 2 times 5. I would check that one. So this is my first equation. 12 equals 2 plus 10. 12 equals 12. So it works in my first equation. Let's make sure it also works in the second. The second one says 2x plus y is 13. So 2 times 4 plus 5 is equal to 13. Let's check that. 8 plus 5, yes, 13 equals 13 again. So as long as it's a solution to both of them, it's a solution to the system. So this last one you're going to try on your own. So go ahead and pause the video and try it. And then when you're done, you can go back and see my explanation. So for this last one, there's many ways to solve. I would go ahead and just double the second one so that my x's were zeroing out. My first equation is negative 4x plus 2y equals 26. I'm not changing it. The second one is 4x plus 10y equals 10. When we add together, we have 12y equals 36. Divide both sides by 12. And y equals 3. When I want to find my x, I'm going to use my original up here, 2x plus 5y equals 5. Remember, you can use any of those equations. And this time I'm going to be substituting 3 for y. So 2x plus 5 times 3 equals 5 is 2x plus 15 equals 5. Subtract 15 on both sides and divide both sides by 2. So x is equal to negative 5. So this one has a solution of negative 5 comma 3. All right, next we've got a word problem. A sports equipment store is having a sale on soccer balls. A soccer coach purchases 10 soccer balls and 2 soccer ball bags for $155. Another soccer coach purchases 12 balls and 3 bags for $189. Find the cost of a soccer ball and the cost of a bag. So we have these soccer balls and we have these bags, so you can envision both of these coaches going to the store. They're buying different amounts of things, but they should still cost the same amount, right? Like a soccer ball is going to cost whatever it costs. It's just they have different amounts of money they're spending because they're buying different amounts of items. So each coach is going to give us one equation. So we need to go ahead and decide on some variables. I'm going to let the balls be x and the bags be y. So let's see, for our first coach, we have 10 soccer balls plus 2 soccer ball bags, so 10x plus 2y, and he spent $155. And then we're going to have our equation for coach 2, and that's going to be 12x plus 3y equals 189. So now I have to figure out how I'm going to solve this. So this is one where I would not want to do substitution. I don't have an x or a y that's easy to solve for. I don't have a variable with a coefficient of 1. It makes a lot more sense to do elimination here. So my x's have bigger numbers in front. I'm going to work on my y's. And 2 and 3 have no factors in common. They're not multiples of each other. So I'm going to have to multiply one of my equations by 3 and the other one by 2. And that would give me a 6y for each. But I need one of them to be negative. So since my first equation has a smaller number for x and a smaller number for 155, I'm going to make that one my negative equation so that when I'm multiplying, all of my negative numbers will be smaller than my positive numbers. So let's go ahead and multiply through now. So when I multiply through, my first equation becomes a negative 30x and a minus 6y, and let's go ahead and do 155 times 3. And that's 465. Now it's negative. My second equation, I'm just doubling everything. So 24x plus 6y equals, let's see, 189 times 2. That's going to be 567. And then as always, when I'm working with something where I have to multiply everything, I always like to go through and double check. So it looks like I did multiply everything in my top one by negative 3. They're all negative now. I tripled everything. And the bottom one, it looks like I doubled everything. You know what? That 567 looks pretty big for something that I doubled. It really should be a number around 400. So let's erase and let's just recalculate that really quick. Maybe I multiplied it by 3 instead. Yep, sure enough, that is a 378. That's why we want to double check. So when I add together, my negative 30x and 24x makes a negative 6x. My y's have zeroed out. And then I have a 465 minus a 378, which is now going to be a negative 87. Okay. So it's interesting because I thought I was making a good choice and multiplying the top one by a negative, but I didn't think about how I was multiplying it by a bigger number. So it actually made everything negative here. But negative divided by negative is positive. 87 divided by 6 is $14.50. So getting a decimal on this problem kind of makes sense. Now I want to go back through and solve for y. So this is the cost of a soccer ball. So to find the cost of the bags, I need to take one of my equations. I'm going to use 10x plus 2y equals 155. And I'm going to substitute $14.50 or 14.5 in for x. So 10 times 14.5 is 145. And then we want to subtract 145 on both sides, and then we'll divide by 2. All right, last is to actually go through and answer this question. So we'd want to say that the soccer balls are $14.50. Soccer ball bags are $5. So at the very end here, we're looking at a little bit of vocab. When we solve a system using elimination, we are essentially, writing a series of equivalent equations or systems with the same solution. This is it for our notes today. As always, if you have questions, please make sure you're asking your teacher for help.